So this is going to be a fun presentation. Really what I'm going to end up talking about is the use of Neo4j and graphs generally across a variety of industries, and then how that applies to both how graphs themselves have evolved, as well as where they're going. So the exercise here, first introductions. We'll talk a little bit about the advantages and graphs themselves from the standpoint of what we're doing, how we're different from other database systems and platforms. We'll talk about government. We'll talk about finance. We'll talk about these digital transformation initiatives that are so compelling. A little bit about myself. I've been with Neo4j for about a year. And in that time, I live in Northern California in San Rafael. That's north of the Golden Gate Bridge. Neo4j is about halfway down the peninsula in the Bay Area, so I have about a 45-mile commute. It takes roughly an hour 15, sometimes an hour and a half each way to get there. So while doing that, I've started listening to audiobooks. And I've listened to a lot of audiobooks. And these are some of my favorites that I've enjoyed. Steven Johnson's Where Good Ideas Come From. And as it turned out, when I mentioned that to Ravi at In-Q-Tel, he recognized it immediately, which was great, and then referred me to the reference material prior to that. The Right Kind of Crazy is a really interesting book about, written by a project lead at JPL, the Jet Propulsion Laboratory, about getting to Mars and putting the largest set of rovers onto Mars. Burglar's Guide to the City is super fun in that it talks about how cities themselves are laid out as mazes, and how criminal behavior is such that they don't look at buildings and they don't look at roads and streets and sewers the same way as you and I would. They look at those as possibly entry and escape routes. Win Bigly is very interesting in terms of promoting influence or talking about influence. It's written by the guy who does Dilbert, Scott Adams. And he uses this idea of how influence peddling operates in society by describing all the major events of the 2016 presidential campaign. And so he was one of the first people to predict that the president was actually going to win the election solely based on his ability to influence people in a variety of different ways. And then, of course, Talk Like TED tells you to tell a story about yourself when you begin your presentation. So the interesting thing about all those books is that they all have a common theme. They all talk about connectedness. And connectedness, so I'm putting up here, and this is for Bryce, who's got the Talk to the Hand sticker on his computer, where we've put up here the social network of Game of Thrones. And you can see how every one of the major families, the Starks, the Lannisters, et cetera, are all connected across the Game of Thrones ecosystem. So a really great example of a social network. And actually one of the, and I thought about putting up Facebook and Zuckerberg in this instead, but decided to really stick with, rather than people who are going before Congress, stick with HBO and some TV. Connectedness in social networks is really the first generation of the graph wave, as was, let's say, applications and systems like LinkedIn or like PayPal in doing money transfers, or Cisco in building routers and networks of connected routers. So this whole idea of connectedness, as it's represented inside of graphs, you can see that graphs really are, or this idea of connectedness really exists everywhere. It exists in an organization. It exists in those social networks. It exists in activities that you might do, like product subscriptions or network operations. Long ago, I got to Reston, and I've been inside the MCI, what was then the MCI Network Operations Center. I think AWS probably runs that right now. Really, really interesting kind of environment. Huge network operations kind of facility. So connectedness is the theme. And how things are connected is where we're going on in our conversation right now. Let's talk about what Neo4j is doing in that regard. We're a graph platform. So graph is the mathematical term for describing connectedness and how things are related. It dates back to, it's about a 300-year-old set of principles, graph theory. Dates back that long ago. And what we've done is we've built an enterprise-grade platform that will actually store, reveal, and then traverse or query all your data relationships across your system. And there's really, really clever things you can do once you understand how one piece of data relates to another, to another, to another, and then some. So the whole goal is to traverse and analyze any level of depth across all of these different networks. It's actually designed to grow and build a variety of different types of graphs. And all the while, you'll hear us talk about, in terms of the technical benefits of what Neo4j does, is offers high degrees of performance, ACID transactions, so the data is always going to be reliable, super agility, right? Our customers, including the ones that are speaking today, probably took anywhere between 3 months and 6 months to deliver their first project in Neo4j. And then they seem to all be iterating on about a quarterly basis. Every 3 months, they're cycling through new stuff, new applications. So that kind of agility is what we're talking about. We'll talk a little bit, my folks will talk about graph algorithms this afternoon and the benefits of developer productivity, how speedy the environment is, it scales like crazy, et cetera. So what I want to end up talking about is setting the stage or setting the premise of where we're seeing and involved in connections. And we're seeing that, the rise of these connections in data across a variety of different types. And we originally cast this as recognizing that, of course, social networks, there's networks of people. Right? But then there's also networks of activities that those people perform. That's our business processes. And then there's networks of knowledge that they build over time, and they want to keep referencing over and over again. And finally, the one I don't put on here is, then there's the network of technology, right? The digital systems upon which you're performing all of these different exercises. So keep thinking in terms of that way. People, processes are the things they do, and the networks upon which they perform those activities. That's really the core sets of principles that Neo4j is operating within. So in the age of connections here, what we're really seeing, and this is really truly starting to happen, you'll see in the use cases I'm about to show you, connecting disparate silos is a universal challenge. I've been in computing for 30 years, right? The activities around how do I connect my CRM system to my customer support system, to my marketing system, to my supply chain. Those are universal problems that, in my early world of business intelligence, we're trying to solve. Always, the themes that you hear from every vendor is connect your siloed data. So graphs are a new take on this. And the beauty of it is graphs are a non-intrusive take on this. They don't require you to throw out anything that you've got right now. They're actually complementary to all of that. And then as you apply them and roll them out, they reveal how connected all of your different data elements indeed might be. And again, that's a theme you're going to keep seeing throughout the course of the day. So the next wave that we're seeing, the current wave that's happening right now, is organizations are figuring out that graphs are a vehicle to drive innovation and really build off of, determine their next major competitive advantage. This is why the theme of digital transformation is so interesting, is because we know that there's disruption going on all over the place. We know that there's, the Ubers and Airbnbs and the like are all, crashing into, or Amazon are crashing into traditional businesses. And the traditional businesses have to react quickly. So graphs are a fantastic way for that to happen. So we'll talk a little bit about how that happens and what we're doing here. So in a typical kind of environment, your typical systems that you have, this is for the 40% of you who have never seen graph or don't know very much about Neo4j. The others, you'll say, yeah, that's exactly what they do. So you're typically storing and retrieving data as tables, as documents, as key value pairs, any way that you want to store it on the left-hand side. But then if you put it into Neo4j, the cool thing that Neo4j does is starts to reveal the connections in that data. And so what's most interesting about that is when we reveal the connections and continue to work through that process, the connectedness actually increases the value of the data that you're evaluating and looking at. So, and we'll keep kind of operating against that theme. And of course, remember, Neo4j, 20 years ago, 18 years ago, we invented this labeled property graph, or this property graph concept of how data was interrelated. And roughly at the same time as Tim Berners-Lee was developing the RDF framework and core pieces of the internet. So, and it's really simple concept is you take your data entities, and I have two people, Dan and Ann. They each have birth dates. They have Twitter handles. They happen to be married. They happen to cohabitate. And Dan drives the Volvo, but Ann owns the Volvo. See, all we're doing is illustrating this idea of connectedness and the relationships amongst people and and objects that they're things that they're doing, and then objects upon which they're doing it, or those digital networks. And we'll talk a little bit, the terms that we use very frequently. Nodes are the big circles. Those are your, almost like nouns in your, if you refer to your data as sentences, right? Nodes are the main data elements. Relationships are the verbs, or what, how these things interact. And then properties are just the attributes that you might apply to these. The beauty of this whole thing is that's as much schema as you really need to understand or know in order to be productive in the property graph. Now, we can apply if you're looking at existing data that you have, and you have to make sure that a customer ID number exists in every one of these lists of properties. You can do that, and you can enforce that. So we have schema enforcement kinds of capabilities built into the system. But that's fundamentally the type of data model that you're building and dealing with. The beauty of that is that that's exactly how we think. That's exactly how we were taught. Like I said, in the data modeling world of 20 years ago, when we're modeling, taking ER diagrams and modeling those out, or data flow diagrams and modeling those, the idea of a data flow diagram is very similar to a property graph. And the beauty of it is, it's looking at how the data elements relate to each other. And the great thing with this is, with Neo4j, is that it never forgets the connections themselves, the relationships, and how important they are. When you're operating in SQL, you're making a table, and the closest thing that you'll have to these connections are your foreign key relationships to other tables. Now, those relationships are often manifested when you run the query in SQL, but then they disappear after that. There's no context for you. The context is not preserved for that relationship. And that's one of the real big differences that we do within Neo4j. It's all about when you're conceiving your idea, you draw it out on the whiteboard. I have a gimmick that I use in sales calls. The gimmick is that I'll walk into, and when we're introducing people around the conference table, I'll get my SE to go up and draw the relationship. So it puts in the account wherever your company. And then as you introduce yourselves, we just jot down your initials and your roles. And then the relationships between you and your other constituents. And then we jot down Neo4j and my role and my sales engineer's role and connect those all up together. The beauty of this is I've just taught that room the most initial elements of graph ideas, and I built an org chart for myself. So we snap a picture, and then the rest of the team knows who we were talking to. So connectedness is this idea that's differentiating Neo4j from everything else. And when I talk connectedness, I am talking about how we conceive the idea of the relationships amongst my data, how I code it, and I have a really interesting, easy-to-use query language called Cypher, how I compute it. Right? I'm always thinking about how to optimize those traversals, right? Those relationships, as it's actually executing in the environment, and then how I store it. Right? All the way down to bare metal, we're thinking in terms of relationships and making sure that that connectedness exists. We've been doing this for, like I said, about 18 years now. The community edition of Neo4j was released about 10 years ago. And has, the uptake of that is astronomical. 10 million downloads of Community Edition thus far. About every year, we're holding events worldwide in about 400 different locations. We've trained more than 50,000 people. We're executing more than 50,000 meetups. We're operating, and right now seeing that there's more than 50,000 instances of Amazon, of AWS, that are actually powering and running Neo4j graphs. So let's talk about a little bit how it fits in your architecture, and then I'll get into some of these use cases. So oftentimes, just revealing connectedness out of SQL information, very, very easy to do. Connecting different disparate silos and evaluating what those connections and those relationships look like from these silos. Again, very, very simple, non-intrusive kind of exercise, but reveals those connections. And then in the largest case, revealing those kind of connections from data lakes and capitalizing on your existing investments in things like Hadoop or other NoSQL systems. Right, these are ways in which we can, the installation patterns that we're seeing of Neo4j. And our favorite sets of use cases, these become actually kind of no-brainers once you start to think about it. Real-time recommendations, fraud detecting, network management and IT operations, master data management, we'll talk a little bit about that. Knowledge graphs, right? Maintaining the institutional memory of an organization and then using that to your advantage. Identity and access management, another great, great one happening and very appropriate for the intelligence agencies, for financial services, et cetera. Okay, and then here's some of my favorite customers that are actually supporting those kind of applications. Walmart, we're powering one of their websites. Itaú Unibanco is the largest bank in South America. They're actually looking at building a system that has, their 4 million account holders, but then they want to see how everything is related to everything else. By 2020, they're expecting to have 93 trillion relationships identified in their system. Right? They're really trying to map out their entire customer constituency. And it's all to make sure that your credit, that their customers are creditworthy, that they are who their identities are valid, and that they're trustworthy to do business with. But we've got HP, Cisco, I'll talk about Airbnb in a sec, UBS on the metadata. Lots of organizations are investing in these kinds of use cases. So in the software space, financial services, I'll talk a little bit about some of the IoT use cases for Comcast and Telia. We'll talk more about some of the retail use cases, et cetera. I think the big thing that we're trying to describe here is we've got over 250 different organizations who are operating projects and tens of thousands of open source users, many of like yourselves, working on Neo4j right now. Graphs are really here. Graphs are really operating very, very well. It's an interesting question, though. I deal a lot with market analysts and things like that, and my question that I pose to them very, very regularly, because I walk up with 25 different customer use cases over and over and over and over again. eBay, Comcast, Scripps Network. I'll show you that one in a second. And what I end up talking about is the connectedness not only in the kind of things that they're doing, but the connectedness of the people in the organizations that they're doing that they're doing it with. So developers are building these real-time graph applications. That was kind of the first commercial set of use cases that Neo4j was chasing down. Generation 1 kind of use cases. Generation 2 gets us to the data hub. And what we're seeing there is both modernization and migration of old systems, legacy systems, into cloud-based systems, like moving from PeopleSoft to Workday. Right? We're seeing and University of Washington is a use case there, where they're migrating 6 hospitals worth of data, right? In addition to the school that has 80,000 students and employees associated with it. Get to the data hub. Right, and make that much more convenient. We'll talk a little bit about GDPR and data privacy regulations, right, and how that affects, or how a graph can actually help with that. We're getting into data science. We're getting into AI situations where the data scientist is looking at what can I do with the new sets of data that I want to add into the graph. And some of the really interesting things are, as I navigate through an organization with these kind of use cases, there's lots of paths through an organization. The biggest observation we have, though, is that graphs themselves are really hungry for data. And when I mentioned that the iteration speed that my customers are going through is like 3 months or less, it's because they want to add more stuff to the graph. Now map this idea back to one of the books I was talking about earlier, this idea of where innovation comes from. Innovation comes from marrying up two disparate sets of ideas and then seeing if they actually click or fit together, making a new node and making new connections, identifying what they refer to as the adjacent possibilities. That's what's happening in here as graphs seek more data. They want to build more connections. They want to add more nodes. And so we're seeing, the strong appetite for data, it loosely fits towards the decades-old now idea of Metcalfe's law of the network. The value of the network increases at the square of the number of nodes or number of users. Right now they're proving that out, that sometimes it's more, sometimes it's less, but it's certainly not, it's still an exponential kind of concept rather than just a linear one. And like I said, we're seeing iterations at like the 3-month cycle right now. So let's look at a couple of use cases here. And these are going to be, they're kind of fun and ideally somewhat localized to the area. So historically, I was raised on the space program. Right? These are photographs from my house and my dad's house. So I've got every mission patch from Mercury on through the first instances of the shuttle, including the Apollo-Soyuz missions and every one of the Apollo missions right there. That hangs in our living room. Right? And then the other picture here, the Aviation Week picture, when I say I was raised on the space program, my dad worked for Hamilton Standard. And they built environmental control systems for the shuttle, as well as the suits for both Apollo and shuttle. So the funny thing that my father would end up doing, and he's actually the guy on the left. So he ran the Space Department, but he also has a really ridiculously big head. So he was actually internally, he's got a 95th percentile head. So he was the one, if a helmet fit over his head, it actually passed QA. If it got stuck on the bridge of his nose, it didn't. I've been to Edwards Air Force Base, that 1977 launch of, or approach and landing test. I saw the fourth liftoff of Columbia down in Cape Canaveral. And, and I'm laying out, the use case here is going to be NASA as a graph use case. But I'm fairly well invested as well as understand many of the use cases and situations that NASA's gone through in their entire history. So it's a huge bucket of knowledge that they've got. And guess what they did? They put it in a graph. It's called the Lessons Learned database. So they've taken all of this historical information about mission information, about successes and failures and trials and errors that they've gone through, this half a century of NASA engineering knowledge, and they applied it to interesting problems like, let's see, if we want to go to Mars, how are we going to get people back? And oh yeah, remember the command module? Every time, when the early iterations of the command module, especially in Mercury, right, when they would splash down and the astronaut would open the hatch, it would fill up with water. One of the astronauts almost drowned. Right? So they didn't want that to happen again and again and again. So how do we make sure the command module doesn't tip over and sink after it hits the water? Right? So they went back to their knowledge graph and said, hey, wait a minute, if we make the command module more buoyant, we put the hatch further up to the top of the cone, and we give it uprighting kinds of ballast capabilities, then it won't tip over. And then we won't jeopardize the safety of the astronaut at the last possible minute where something could go wrong when they return home. So the impact of this particular graph is pretty substantial. We've measured, David Metz is quoted as saying, we saved probably 2 years of investigative work on that exercise and well over $1 million, right, of taxpayer funds in solving just that problem. But they continuously use this knowledge graph over and over again as they look and plan for future missions. I'm going to talk about ICIJ, another one of our favorite, very public, very popular use cases. customers. ICIJ, of course, is the International Consortium of Investigative Journalists. That's the first acronym you need to learn when you join Neo4j. So ICIJ is a team of about 300 journalists, and what they've been working on, or they periodically are working on, are leaks of information, usually financial record leaks. And their first major reporting out of this was the Panama Papers in 2017, or 2016. And Panama Papers, of course, figured out, it was a Snowden-style leak, like somebody walked out with a hard drive, 11.5 million documents on it. It had information like people who own accounts at a bank. And then it figured out stuff like, well, those people live at a particular address. They live with somebody else, probably a spouse, who is an officer of an offshore company, a holding company, with accounts at a bank in the Bahamas. So simply tracing with these 6 hops from the paycheck of a popular professional person, right, channeled through their spouses, actually revealed where they're hiding their taxable income in offshore accounts. That was the Panama Papers leak. Right? As a graph, it looks exactly like this. Person A with their account, there's my node, there's my relationship, and you can see how I would traverse around this to go from their income all the way to their tax haven. Well, in 2017, right, ICIJ and journalists from McClatchy, the Herald, New York Times, they won the Pulitzer Prize for investigative journalism. Because this was, until Brexit and the election, this was the biggest story of 2016. And so the other interesting things that had happened with this, though, is that it identified the holding accounts of celebrities, of gangsters, and of very high-level politicians, including oligarchs, including prime ministers. It brought down the Prime Minister of Iceland. He resigned after this was revealed. It brought down, last year, the Prime Minister of Pakistan, right? ICIJ's investigations. Well, guess what? They did it again. Paradise Papers, different leak. Instead of being the Panamanian law firm, this is a 100-year-old law firm called Appleby, right? And Appleby is even more documents, 13.4 million records, about where companies and people are putting their tax shelters. One of the interesting ones that it revealed was, remember when Apple was brought up in front of the EU about repaying their taxable income in the European Union. And at the time, Apple had held all of their corporate accounts in Dublin, Ireland. Well, what they did subsequently is, after the EU got them for something like $14 billion, they moved all of their accounts to the Isle of Jersey in the middle of the English Channel. The Isle of Jersey has a population of about the size of this room, but very, very favorable taxable income kind of regulations. So again, ICIJ did it again, and one of the other cool things that has gone on is they were recognized at, not only they won the Pulitzer Prize last year, this past year, they were granted $1 million in endowment from the Hollywood Foreign Press Association. Those are the Golden Globes people, right? In order to keep keep their activities going. So the Paradise Papers, so that's the kind of the interesting human interest side of the story. The graph of Paradise Papers is really simple. Right? It's just officers of a company, right? They're connected to something else, and connected to another entity, which might be an address, might be a different type of an intermediate entity, right? But that's the structure, the metadata model of the Paradise Papers and Panama Papers leaks database. When you draw back the lens on that, this is what it looks like. And you can see Appleby is the big firm there in the lower right-hand side, but then there's other clusters of information that are revealed simply by putting all of that information in the graph and zooming in and out of the graph. Let's take this idea of detecting fraud and carry it forward a little bit more, and why graphs are so appropriate for that. So oftentimes, traditional fraud detection measures, they look at things like, what's the final endpoint of the transaction? And did the transaction match where I think that particular user is? So remember, your bank is constantly calling you with, hey, somebody in Cleveland just ran your account. Is that you? It was only for $6, right? That's kind of endpoint-centric analysis. There's navigation-centric analysis, right? Is there any kind of navigational behavior like, what's the IP address that customer is using with that account? So that's always tracking the cookie. Your bank is tracking the cookie of your machine, like your MAC address, your IP address, et cetera. Remember, it always says, do you want me to remember this machine? That's that kind of fraud detection. And then account-centric is comparing transactions and vetting identity, really kind of basic things, right? The bummer is it doesn't really examine things like rings of people, right? Coordinated operations amongst individuals, IP address faking, hijacking devices, synthetic devices. So if we apply the connectedness model and do connected analysis, then we can look at things like cross-channel, find the anomalies and weird behavior of coordinated individuals. We can look at things like linking entities. So let's look at whether the relationships between one account holder, another, and what do they have in common and what do they don't have in common, and is that right? This is what that looks like. So modeling fraud transaction is an organized crime ring. So at first glance, I've got my account holder, they have a credit card, they have a bank account, they have an unsecured loan that they're all operating within. 3 people have set up similar situations here, right? They have multiple types of accounts, et cetera. What makes it really interesting when you model it as a graph and you look at, hey, wait a minute, they have a common phone number amongst them. So that could be location and identity information. They have a common social security number. That's really a red flag amongst a couple of them. And there's a common address. So they're operating out of the same location, perhaps the same apartment, and using similar information and then just dispersing it amongst a whole variety of different accounts. Really, really easy to understand types of identifying relationships amongst people, the weird activity that they're doing, and the networks that they're doing it on. So that was fraud. Let's look at our other favorite topic of the month, GDPR, and tracking regulations and activities across this is, again, a financial services kind of firm, but most of these are either identity or financial traceability kind of transactions and activities. So if I'm looking at internal risk models, I have things like in a big financial services firm. I've got my trading desks, I've got my fund managers, I've got the actual trades and activities I'm performing, core banking activities like loans and savings accounts, checking accounts, and then everything that's going on in the market. When I look at even just tracing the risk lineage of the activities that the trading desks are performing against the baskets that they might be performing and operating against, like my technology desk is trading in cloud computing. It's got a lot of equities associated with that, and then I want to see what's happening in the market there. So these activities and all of this risk analysis here, what's required by the SEC is to be able to trace forward and backwards all of these different kinds of activities and how they're interrelated. So you can see, right, evaluate the interrelatedness of all of these things in order to verify that the risk that they're carrying in performing trades, they have enough equity and trading capability, trading power to actually execute those. Got another great one of the role of ontologies. These are catalogs of information. FIBO, the Financial Industry Business Ontology, is a great one. Usually it's performed with RDF technology, triple stores, right? Because they're great at organizing catalogs. Well, FIBO as a data model has about 13,000 triples in it associated with it. But when we move that into Neo4j in a property graph, while maintaining all the same fidelity that was required of the FIBO model, we brought it down to 1,300 nodes. So we shrunk the size and complexity of the RDF store down to about a tenth the size of what it was previously. And these operate against all kinds of different regulations and different types of financial trading models and financial management models. Let's talk about knowledge graphs for a second. Got a great customer, Scripps Network. These are the HGTV, the Food Network, Cooking Channel, Travel Channel, right? The channels that you watch, on when you're in a hotel room or late night TV and want to see, all right, where are people moving, right? Where's the Property Brothers, et cetera, right? So, developer of lifestyle-oriented content for digital media, they make a knowledge graph of all the media properties that they happen to own. And now they're owned by Discovery Networks, who happens to be a local organization here in Arlington. Is anyone from Discovery here? Just for you guys. Just for you guys. Okay, so Scripps has this content management environment where it's figuring out not only every one of the episodes of Rachel Ray, but it's also figuring out and tracking what are the cameos that Rachel Ray is making in other TV shows, and what's the most popular set of videos or YouTube content that's getting played off of these episodes. So they've tagged all the content with who the characters are, what the legal rights to each one of these are, what the original television format might be, who owns the rights to that. Those kind of things are built into the Scripps Network knowledge graph. And then I've got Airbnb's data portal. Right? This knowledge graph is actually a metadata model that's taking all of the data that Airbnb is collecting worldwide and integrating all of those different silos and looking at the kind of reports that any one of their Airbnb employees are actually running. Because what they really want to do is maintain high degrees of consistency of how they're reporting out activity, like, is this a really popular property? Why isn't this one reserved all the time? So, and then also, who are the individual information providers inside of Airbnb that are really the go-to people who have the most accurate information, the most popular sets of reports, et cetera. That's what the data portal does. And so it's serving about 3,000 plus individuals inside of Airbnb, and it's a really, really simple knowledge graph of what things are popular, what things are not. And it's all based on data elements that they're tracking. All right, our final bit here is let's talk about where this is going. And as David mentioned earlier, digital transformation is affecting every kind of organization, right? Driving new ideas in innovation is really, really important for an organization, especially if you're a retailer and Amazon is chasing you down. Or if you're a taxi service or a travel service and Airbnb and Uber are tracking you down. Right? Coming up with new and clever ways to deliver a highly engaging customer experience, recognizing exactly where they happen to be at any given time, the activities that they're doing, right, those digital networks that they're performing activities on, is a real key initiative in many, many organizations. How many of you guys have digital transformation type activities going on in your organization? I got a couple. That's good. There'll be more. So let's look, a couple of really interesting things here, and this is highlighting how graph can actually be applied to those transformation exercises and the reasons why that's, that's actually a good thing. One is really the Gartner quote. My customers told Gartner Group the reason why they chose Neo4j was to drive innovation. And remember what I started out with? I keep going back to that adjacent possibility idea. Driving innovation requires you to identify new adjacent possibilities. Those are graph terms. Graphs help you drive that. So there's all kinds of other ways to look at digital transformation, these kind of mega trends that are happening, whether it's innovating on things like drug discovery in the pharma industry, performing hyper-personalization kinds of activities for recommendations, for healthcare tracking, for media advertising, et cetera, our Facebook-style use case. Improving decision-making improving data integration, supporting AI initiatives. The knowledge graph is a great example of supporting an AI initiative. So let's talk about one of my other favorite use cases, eBay ShopBot. This is a conversational commerce application that operates in Facebook Messenger and actually has its own app now in Google Play as well as the Apple Store. And what ShopBot actually does is it allows you to log into it and say, either talk to it, say, hey ShopBot, I want you to find me a new product. Right? You can speak it, you can feed it a picture, or you can type in your particular set of responses. And this chatbot on the backside of eBay is figuring out whether they actually have products for you or not. Right? Really kind of basic thing. And then they present it back to you. But they also communicate with you and ask you contextualization questions while you're in conversation with it. So if we look at kind of the context of things, of information that a customer might provide, instead of saying, I need a new backpack, right? Is this example. So contextually, you might type out or ask, can you find me a brown leather Coach messenger bag under $100? And look at the context that this is actually identifying here, right? Color, material, brand, what the object itself is, and price point of what the object is. This is what eBay is parsing out and actually remembering about any one of their products for sale. And they're actually mapping that back to whatever you're actually requesting as you're conversing with ShopBot. It looks like this. So here's my bags are in the middle there. And the questions that it's going to ask me are things like, OK, you want a bag. Do you want it to be a handbag or a backpack? I'll pick backpack. Then it's going to ask me, all right, what color? Brown or black? Or what material? Leather or canvas? What's your price point? So it'll go through that. And then the really cool thing, and this is where the AI and the advanced kind of customer experience comes into play. The cool thing that ShopBot is doing, and again, they're iterating on this 3-month cycle. What they're doing now is they're remembering contextualizations about the customer, right? Attributes like, what's your shoe size, right? Attributes like, I'm left-handed, right? So when I shop for sports equipment, right, or scissors, I need stuff like that support my handedness. And I want ShopBot to actually remember that when I bought the First Baseman's mitt, it was a lefty, so that when I go and get golf clubs soon, because the Masters was just on, and that was a really good Masters this year, right? When I'm getting clubs, I want it to offer me lefty clubs. So that's the contextualization that they're doing now. What they're going to be doing later on this summer is adding in even more context. Where are you located? What's the climate like? What season is it? Is this a gift for somebody else? What's the anniversary or holiday? Right? So it's building out this institutional knowledge, this contextualization, and then presenting that back to you as you shop with it. Their privacy controls are actually quite strong here, unlike the Facebook has been watching my telephone calls for years. So check out ShopBot. It's very fun to play with. It is actually generating revenue, which is part of this transformational kind of experience inside of eBay. And we've got a number of other similar types of use cases, like even as you're operating inside of in your mobile application, there's so much contextualization that you can actually derive and apply within any one of these applications. Right? And the graph behind those online stores, they have product information, customer information, supply chain information, delivery information, all of those are built into these variety of graphs. And as I mentioned earlier, Walmart is another one of these vendors who's using Neo4j. Let's talk Internet of Things. IoT is really big right now, right? Self-driving cars, smart homes. Xfinity XFi, a Philadelphia-based project here on the East Coast. This is one of our customers, presented at Graph Connect last year. XFi is the customer experience that Comcast is building to integrate not only your router information, like they know who's in the house at any given time, they'll tell you when your kids get home, stuff like that. They take the router information and map it to your phone. They take the entertainment information, your preference for shows that you want to look at and watch, or who watches what types of programming inside of your household, right? Kids programming versus Game of Thrones. And then they're also mapping that up with security information of your house, whether you left your garage door up, whether somebody's at the front door, whether, and whether odd things are moving around, like, you never let the cat out. It's tracking all of that information and creating this very, very interesting and experiential kind of customer experience under the X5 brand, right? This is what their quadruple play or their triple play is really going for. And so you can imagine this is not only a customer mobile network devices kind of environment. It really is the exemplification of what you can do when you get into the ideas around Internet of Things. Let's look to the next set of technology. What's coming up next? Blockchain. You know what blockchain really is? Blockchain is pretty easy to understand. It's a public ledger. It's tracking all the transactions that might happen against anything. And then it distributes those transactions across a networked environment so that everybody has the public record. It's encrypted, so it's safe, and you might not know the absolute identities of everyone. But those transactions indeed are available and decentralized. So there's no central certifying authority that says these are not true transactions. You see this in cryptocurrency right now, and that's what most people are associating blockchain with. But this goes well beyond crypto, right? It can actually handle your purchase transactions, your communications, your things that you buy, et cetera, right? It can be used for all kinds of different types of transactions and different types of exchange, eliminating the need for, in real estate, all of that paperwork you have to sign off on when you buy your house. So that's where graphs are going. Graphs are the foundation for blockchain ideas. Graphs are the foundation for machine learning and deep neural networks, right? Guess what your favorite deep neural network is, right? It's your brain, right? That's a graph. So we're moving in that direction. I'm starting to characterize this as the third or fourth generation of where graphs have been going, have come from the origin of the internet as a network, social networks, then into the real-time recommendation space, into the metadata management space, now into AI, deep neural networks, blockchain, Internet of Things. Foundational technology for all of this. So your assignment, this concludes my prepared remarks. Your assignment today is, of course, connect with each other, right? Find an adjacent possibility. The great thing about this, about the rest of this day, got awesome examples from customers, from Dan, to plant in your head of, my favorite thing about Dan's presentation is just its headline. What's your $100 million idea? Ravi's actually next. He's going to show you how to assemble it. So thank you very much, and I'm here all day. So I would love to talk to you and get to know you guys.